Hello everyone, welcome to this playlist of JEE Advanced previous year questions for Kinematics. This is the second video of this list and second question as well. So again this question was asked in JEE Advanced 2025, okay. So and it was again the numerical based, okay. So as you can see in the question it is given there is a projectile of mass 200 gram is launched in a viscous medium at an angle of 60 degree with the horizontal with an initial velocity of 270 meter per second. It experiences a viscous drag force minus CV, where the drag coefficient is 0.1 kilogram per second and V is the instantaneous velocity of the projectile. Okay, the projectile hits a vertical wall after 2 seconds. Taking E is equal to 2.7, the horizontal distance of the wall from the point of projection in meter is. Okay, cool. So as usual everyone can pause the video and try to solve this question, and once your attempt will be done we can resume. Okay, now let's start. I am expecting that everyone has tried to solve this question. So what is given? It is a simple projectile motion, okay, but the only difference is that at every time there is a drag force, or we can say a kind of frictional force or resistance force, which is exactly in the opposite direction of the velocity. Okay, so the drag force which we are receiving is let me change color. Okay, so the resistance force or drag force which we are getting is in the direction of the velocity, or sorry, in the opposite direction of the velocity. Okay, minus means opposite of the direction of velocity vector. So if suppose this is a projectile, okay, so at this instance of the time force will be in this direction. Okay, suppose after some time object goes up to here and its velocity is in, just I am drawing it randomly, if velocity is in this direction then force will be in the opposite direction. Okay, similarly if at this point of the time, if suppose velocity is in this direction, force will be in the opposite direction. Okay, so this is what we can interpret from this point. Okay, and what is given, and it is given that projectile hits a vertical wall. So suppose from here we have initiated the projectile, okay, and anything could be a trajectory. It hits a vertical wall here. Okay, this is a vertical wall after 2 seconds. So the time between suppose at t equal to 0 we initiated a projectile, at t equal to 2 seconds that ball hits a wall. Okay, and we are not sure in which direction ball hits the wall. Okay, so it could hit the wall like this, it could hit wall like this, it could hit wall like this. Okay, the direction of velocity of ball could be in any of these three direction, or could be anything. Okay, it is not given. What it is given that they hit the ball after 2 seconds. Now we have to figure out what is the distance. Okay, what is the distance between the point of initiation of the projectile and distance between point of the initiation of projectile to the wall. Okay, we have to figure out the distance. So what we need to do, see, we can understand that what eventually we need is, we need distance as a function of time. Okay, if we will have this, we can figure out the, we will put the value of time and we will get the distance, right? That is the only possible way of solving this, right? Because it is the only thing which is given is that at what point of the time, at what time ball hits the wall. It is at 2 seconds. So I need distance as a function of time. I will put the value of time here and get the distance, right? Okay, so let's see what all we can do now. Okay, our goal is to get this equation, distance as a function of time. Okay, let me erase all of this and try to, sorry, give me a second. Let me erase all this and try to solve it. Cool. So mass is given at any point of time, suppose at projectile, suppose this is the velocity. Okay, so to make my life easier, what I gonna do is I will do two things, Vx and Vy. Okay, projection of velocity in the direction of x-axis and in the direction of y-axis. Okay, in the direction of x-axis and the direction of y-axis. Okay, so this will be the velocity component, and if I draw the free body diagram, what will be the forces at this point of time? At this point of time, there will be one force mg and the friction force or resistance force in the opposite direction of velocity. Okay, so for Vx, force will be in this direction, which is Cvx, and because of Vy, there will be force in this direction, which is Cvy. Okay, so this will be the free body diagram. Okay, at any point of time t. I hope everyone is clear with this. Okay, at any point, if it has two velocity component, one is Vy and one is Vx, then there will be two resistance force. One is in x direction, which is Cvx, and another one will be in the opposite direction, which is Cvy. Okay, opposite of velocity. Okay, and I can write here to avoid the confusion. V is nothing but Vx I cap plus Vy j cap. Okay, Vx and Vy is nothing but horizontal and vertical component of the velocity. Cool. Now let's see what all we can do. So what we do know is F is equals to ma. Okay, if I write, see the wall, we have to figure out the horizontal distance. Okay, we have to figure out the horizontal distance. So initially I am interested in the horizontal components only. Okay, so Fx is equals to max. Can we write this? Okay, we can write this, and the only force in the horizontal component is Cvx. Okay, Cvx is the only force in the horizontal component. Mg and Cvy is the force in vertical direction, in y-axis. So for the horizontal, what I can write is force, which is minus Cvx, okay, is equals to max, and acceleration in the x direction will be nothing but, acceleration in the x direction is nothing but ax. I can write it as dvx by dt. Okay, I can write it as dvx by dt. Cool. Anything else which I can do out of this? So this thing is, I can get velocity as a function of time here, right? I can get velocity as a function of time. Will this solve my purpose? Will it solve my purpose? Yeah, it can solve my purpose. And velocity as a function of time will, if I will get velocity as a function of time, if I will integrate it, it will give me distance as a function of time, right? What if I write it as velocity as a function of x? So I will get x as a function of velocity. Let's try to solve this equation only. Okay, so if I want to solve this, what I can do is minus c dt is equals to m dvx by vx. Okay, so this is nothing but, if I want to solve, if I will integrate it from 0 to t seconds, I will write Vx initial to Vx. Okay, if I integrate it, what I will get, minus Ct is equals to m ln Vx, okay, m ln Vx, and m ln Vx minus m ln Vx initial. Vx initial is nothing but, we can get, okay, Vx initial is initial velocity in the x direction, okay. So minus Ct is equals to m ln Vx by Vx I. Ln A minus ln B is nothing but ln A by B. Okay, so I am getting this equation. Okay, so if I want to write it back, what I can rewrite it as Vx by Vxi is equals to e to the power minus Ct by m. I hope everyone is okay with me. Okay, if I can rearrange it like this. For newbie, I am just writing, if ln A is equals to B, we can write A is equals to e to the power B. Okay, this is the basic thing which I have used over here. So Vx is equals to this. So what we got velocity in x direction as a function of time. So Vx is equals to Vxi e to the power minus Ct by m. Okay, will this solve my purpose? No. What I need distance as a function of time. Okay, so okay, what I can do is I can write Vx as dx by dt, right? Velocity is nothing but rate of change of displacement. So dx by dt is equals to Vxi e to the power minus Ct by m. And again, if I will integrate this, okay, so again if I will integrate this, dx is equals to Vx I, okay, Vxi e to the power minus Ct by m into dt, right? So if integration of dx is x from 0 to any time x, x minus 0 will be x, okay, and what will be the integration of this? Integration of this will be Vxi into minus m by c. I hope I am writing it correct. I am doing all this integration differentiation after a long time. So integration of this will be minus Vxi m by c e to the power minus Ct by m from 0 to t. Okay, so if I rewrite it, what I will get, x as a function of time t is equals to minus Vxi m by c e to the power minus Ct by m, and then if I will put 0 here, so it will be 1, and minus of minus, so it will be 1, and this is nothing but plus Vxi m by c. Okay, so if I rearrange it, I will get x is equals to Vxi m by c 1 minus e to the power minus Ct by m. This is my desired equation. What I needed x displacement in x direction as a function of time. Okay, now what was given? It was given that it hit the wall at t equal to 2 seconds. So what we need to figure out? We need to figure out at t equal to 2 seconds how much horizontal distance it traveled. So which equation will give us this value? This equation. Okay, x as a function of time t. If I will put t equal to 2, Vxi m by c 1 minus e to the power minus 2c by m. Okay, now this is a huge maths which we have to do. Let's see what was vxi, what was m, what was c. I don't know what was c. Okay, c was the coefficient. Okay, c is given as 0.1 kilogram per second. Okay, and what was the horizontal velocity? U at an angle of 60 degree. Okay, so at t equal to 0 and mass is 200 gram. Okay, we have to use all this thing. Okay, so mass is 200 gram. If I write it in kg, it is 0.2 kg. C was, again I forgot, C was 200, U was 270 at an angle 60, C was 0.1, C was 0.1. Okay, C was 0.1 and U initial velocity was 270 meter per second at an angle of 60 degree. So what will be Ux, or sorry, Vxi? Initial velocity will be 270 cos 60. Okay, U at an angle of theta, so horizontal velocity will be U cos theta. 270 into cos 60, which is 135. Okay, so Uxi is 135, C is 0.1, mass is 0.2, so 0.2 by 0.1 is nothing but 2. 135 into 2 into 1 minus value of E is 2.7, again 2c by m, 2 into c by m, 2 into 0.1 which is 0.2 by m which is 0.1, so 2.7 to the power minus 1. So what we have to do, 270 into 1 minus 1 by 2.7. Oh, this is quite beautiful, I can solve this. 270, 2.7 minus 1, 1.7 by 2.7. Okay, so this comes out to be 2.7, 10, 100, it is equal to 170. Okay, so the horizontal distance will be 170. Okay, I hope this is in meter, I guess. Yeah, this is in meter. Okay, so 170 meter. Yeah, the point of projection in meter, answer will be 170. So this was basically mathematics, है ना? We should understand what is the basics of kinematics, what is velocity. So how we solve this question. So after reading the question, we know that there was some complexity. We have to take care of the resistance force. Okay, and it was given what was the time at which it hit the horizontal wall. Okay, and we had to figure out the distance. Time was given and we had to figure out the distance. So definitely it should click in your mind that okay, I need distance as a function of time. How we can come to that equation? We know the basic Newton's law, force is equal to mass into acceleration. Okay, so first I did force into mass into acceleration. Force was function of velocity in the horizontal direction. In the horizontal direction, force was the function of velocity. So I rewrite force as cvx into dvx by dt. Solved it, I got velocity as a function of time. Solved it, I got velocity as a function of time. Then I again replaced velocity as dx by dt. Okay, velocity is nothing but rate of change of displacement. So when I put it back dx by dt, I again integrated it and got displacement as a function of time. Okay, displacement as a function of time, and then nothing, we just put the value of all the constants. Okay, and we got the answer. So we should be very well versed with the integration, differentiation. Okay, and another thing which made our life easier is always I tell to my students that you should always take the component of all the vectors in 3 mutually perpendicular axes. If it is 3-dimensional problem, if it is 2-dimensional problem, take components in the 2 mutually perpendicular axes. That will make your life easier because we don't need to take care of another axis while taking care of one particular axis. Okay, So yeah, that's it. I hope you guys like the solution. If there is any feedback, please do comment, and let's meet at the next question for this series of all the kinematics. Our goal will be to solve all the JEE Advanced question of kinematics in the past 20 years. Okay. Thank you. See you guys.